So in the previous video, we saw about a class of DFA that was with output. So the general DFA, the first type of DFA that we have seen is a DFA that gives a yes or no, or an acceptance or a rejection decision making. So it gives a yes or a no decision, or acceptance or a rejection decision. That is found with the final state. So we have a set of final states. So after the entire input is traversed, if the machine is in one of the final states, then it is accepted, the input string is accepted, or the input string is rejected. So the second class of DFA is DFA with output, and we saw two types of machines, Mealy machines and Moore machines. So these two type of machines, for a given input string, doesn't take a decision whether the string is accepted or rejected. Instead, they emit a single output symbol or a group of output symbols. So Mealy machine we have seen in the previous video, and now we are going to see a class of machine called Moore machines. So in Moore machines, we don't, in both these class Mealy and Moore machines, we don't have a final state. So the final state we are not going to accept or reject based on reaching the final state. So instead we have these two, a set of output alphabets similar to the set of input alphabets. We have a set of output alphabets and also the output function. And in Moore machine, the transition function is same as DFA. For the, it depends upon the current state of the machine, the current input symbol, and decides the next state. The transition is decided based on the current state and current input symbol. The next state is decided, whereas the output function depends only on the current state. It doesn't depend on the input symbol, it only depends on the current state. So given a current state, so when a state is reached, an output symbol is emitted. It is not with respect to the transition. So when multiple transitions could land on a state. So when a state is reached, an output symbol is emitted. So the output function depends upon the current state to emit the output symbol. So given is a Moore machine over here. So as we can see, the output symbol is not part of the transition as we saw in the Mealy machines. Here the output is the output symbols are part of the states. So here the Q0/1, this 1 is a output symbol emitted whenever the Q0 state is reached. So Q0 is the initial state. So initially also Q0 is reached, and there are other transitions that land on Q0, that is Q2 sees a 1, then also we land at Q0. So whenever Q0 is reached, an output symbol 1 is emitted. So similarly, whenever Q1 is reached, the output symbol 1 is emitted, and whenever Q2 is reached, the output symbol 0 is emitted. So here the set of output alphabets are O is a set that represents 0 and 1. So these are the output symbols emitted. So for the input string 101 or any other input string, if we try to trace, so 101. So what happens in this machine is, so first it is at Q0, Q0 sees a 1, so it moves to Q2, Q2 sees a 0, right, so this is a 0, so Q2 sees a 0, it moves to Q0 again, and Q0 sees a 1, it moves to Q2. So for this input string, what is the output string that is emitted is, we will write the corresponding output symbols for every state. Q0, the output symbol is 1, Q2, the output symbol is 0, Q0 again the output symbol is 1, Q2 it's 1, and Q2 the output symbol is 0. So it's a 1 0 1 0. For the input 1 0 1, the output that we've got is 1 0 1 0. We usually omit the output symbol corresponding to the start state, and we take the remaining as the output emitted. 0 1 0 will be the output. So whenever a state is reached, and on traversing the input symbol by symbol, we do some state transitions. So whenever a state is reached, an output symbol is emitted. So, for given input string, the DFA emits an output string and it does not take a yes or no decision for this Moore machines. So, let us construct an example Moore machine for 1's complement. So, in 1's complement, we just flip the bits, flip the bits. If the input is, for example, 100, the output would be a flip of all the digits like 0, 1, 1. So, what if we realize this with the Moore machine? So, Q naught will be the initial state. So, it has two paths, a 0 and a 1 path. So, it has two paths. So, let us say Q naught emits a 0. So, whenever I land at Q naught, it emits a 0. Okay. So, Q naught emits a 0. So, in the 0 path, so when the input is 0, it reaches Q1, but it has to emit a 1 because it is a complement. When input to Q1 is 0, the output should be 1. Okay. So, 1 should be emitted. When Q1 is landed, it is landed the state, we land in the state by seeing a 0. So, for 1's complement, when I see a 0, I should emit a 1. So, similarly, Q naught I am seeing a 1, here I will have a new state Q2. So, the input here is I have reached Q2 by seeing a 1. So, the input is 1, so I should emit a 0 because it is 1's complement. So, whenever I land on the state, I try to emit an output symbol. So, to complete it, how do we complete the DFA? So, we should complete the handling of all symbols like at every state. Now, let us say Q1, Q naught is already complete, we have handled both 0 and 1. So, Q1 on seeing a 0, what happens? So, when it sees a 0, it has reached Q1 by seeing a 0. So, I should emit a 1. So, I will self loop on a 0. I will self loop Q1 on a 0. So, while seeing a 0, it will emit 1 as output. So, similarly for Q2, I will self loop on a 1. So, when I see 1, so when I land at Q2 by seeing a 1, so Q2 should emit a 0 as output. So, we have handled for both Q and Q2, we have handled 0 and 1. Now, what if sees Q1 sees a 1? So, Q1 sees a 1 means I should land at a state that emits 0. So, at Q1 which sees a 1, I land at a state that emits a 0. It is going to emit a 0. So, I go to Q2. Similarly, what happens when Q2 sees a 0? I will land at a state that emits 1 because it is a flipping of bits. So, now we have completed our DFA. Now, if we traverse through this string 100 which we have as input, we will check if we are getting the 1's complement correctly. 011, we should get 011. So, this is the input string, 100 is the input string. Now, let us write the state transitions for this. So, this is the initial state, Q naught is the initial state. So, Q naught is the initial state, Q naught sees a 1. So, we move to Q2. Q2 sees a 0. So, we should move to Q1. Q2 sees 0, we move to Q1. Right. So, Q naught sees a 1, we have moved. Q2 sees a 0, we have moved to Q. Now, Q1 again sees a 0, we stay in Q1 when it sees a 0. So, these are the transitions for the given input symbols. Now, let us, so we have landed in these states. We have landed first in Q naught, then in Q2, then on Q1, and again we have stayed in Q1 for reading each of the input symbol. Now, let us write the output symbol emitted by every state. So, Q1 emits a 0, Q2 emits a 0, this emits a 1, and Q1 again emits a 1. Right. So, we will usually omit the symbol for the start state, and we have got the 1's complement. So, we have constructed a Moore machine for flipping the digits, and for a given input string, it will emit, it is not going to accept or reject the input string, it is going to emit the ones complement answer for the given input string.